Hey kids, Smath here. So now we're going to do some free energy calculations, some spontaneity calculations. Now remember, we just got done saying that negative delta G, it's a terrible G, is spontaneous, and a positive delta G is non-spon. And we're going to use two different formulas to calculate delta G. The first one we have, which is delta, sorry kids, delta G equals delta H minus T delta S. We're going to have some unit issues on that one. We're going to do that one up first. And then in the second one, we're going to do standards. And that's going to be delta G for this reaction is equal to delta G of the products minus the sum of delta G of the reactants. These are two very simple calculations, very straightforward, and we've got Texas Instruments to help us out here, so I think we're going to be just fine. Let's look at our first problem here. It says at 298 Kelvin, the decomposition of aluminum oxide to aluminum and oxygen has a delta HF and a delta S. What's delta G? So this problem, they're giving us some delta H. They're giving us delta S. We just got to do delta G. The only thing to be careful of here is watch your units. In this case, we have delta H in kilojoules per mole, and we have delta S in joules per Kelvin mole. Now that Kelvin's going to work itself out because we've got this 298 going on up here. That's going to help us get rid of that Kelvin. But before we do that, we have to convert that joules to kilojoules. So that S is equal to 0.05092 kilojoules per mole Kelvin. All I did was divide that value by 1,000 to go from joules to kilojoules. Now I've got everybody in the same units. Now we can do a delta G is equal to delta H minus T delta S. H is negative 1675.7 kilojoules per mole minus T, 298 Kelvin. These have to be in Kelvin. And S, which we just converted, 0.595092 kilojoules per mole Kelvin. And now we can see our Kelvins cancel out with our Kelvins here quite nicely. And if we do this, delta G ends up being negative 1690.87 kilojoules per mole. And I think because of our sig figs, we're probably safer making that 4 sig figs because of our entropy and our temperature here. Okay, 1691 kilojoules. Negative delta G, spontaneous reaction. This is going to occur as written at that temperature. So that's my delta G equals delta H minus T delta S. Now let's look at the standards. Free energy is standardized. It's called the standard free energy, delta G naught. And it uses standard entropy. So anytime you see these degree signs like that and that and that, I know they look like zeros. They were supposed to be degree signs, but they didn't export very well out of PowerPoint. My apologies, okay? The free energy involved in the formation of a compound under standard conditions is the standard formation, the free energy of formation. And it says table 563. I'm going to put that table into Canvas for you guys, okay? Because I know the page numbers are all out of whack with the online book, all right? Our units here are going to be in kilojoules per mole. These are going to help us when we go to do delta G standard. And what's that G that we're looking at here? This is going to be delta G of the reaction is equal to the sum of the products minus the reactants. We got to watch out for coefficients here, okay? But they're going to work themselves out. So given the following, calculate delta G prime, G0, for the following using the calculated or the tabulated values. So they're giving us these. All we have to do is say delta G for this reaction is going to be equal to delta G of N2O plus delta G of NO2 minus delta G of NO. And this 3 is going to come into play over here. This is what it looks like. So we're just going to take 104.18 kilojoules per mole times 1 mole plus 5131 kilojoules per mole times 1 mole. How do I know that's 1 mole? There's a 1 coefficient that's implied. It's not written, but it's implied right before those two in the equation. All right, minus now 86.55 kilojoules per mole. And now that 3 is the number of moles that we have, times 3 moles. Okay, if I munch them, crunch them, put these in, I'm going to get a negative 104.16 kilojoules per mole is delta G. And we've got a spontaneous reaction. Thermal decomposition of NO breaking apart to N2O and NO2. So these are 2 forms of calculations. In the first one, we actually did delta G equals H minus T delta S. And in the second one, we did products minus reactants. Okay, I'm Smath. These are our Thermo Calcs, Thermo 2. I hope this video helped.